Do you think there are any aliens out there in space? And by that, I don't mean things like jellyfish or worms or bacteria. I mean, do you think there is any intelligent life out there? Who knows? I suppose the truth is that nobody actually knows the answer to that question. So this is just my personal opinion. But I do want you to tell me if you have a different opinion. Let me know in the comments and give me as many details as you feel able to. And yes, even if they don't admit it, most people who spend a lot of time out in the outdoors, because they have a lot of time to think, they will think about strange things. And depending on your viewpoint, their thoughts could be described as either very deep and philosophical, or, which is normal in my case, completely stupid. So what's going on? Well, I'm sitting here alone in this forest, and this made me think, how alone is it actually possible to be? So I've just used my calculator to work it out. Let's assume that there are, trying to think, approximately 8.3 billion human beings on Earth. And there is a total landmass of around 150 million square kilometers, or that's roughly 58 million square miles. I seem to remember from somewhere that only around 43% of the land can actually be lived on. So I've discounted things like ice sheets, deserts, high mountains, etc., etc. This means that if all the people on Earth were equally spaced apart, each person, man, woman and child, would have approximately 7,700 square meters. That's just over 1.9 acres. So that if they were all stood in the center of their square patch of land, they would be only 88 meters, 289 feet from their neighbor, and so on and so on. So even if we spread out everyone equally, the Earth is still very crowded. But again, as I'm sitting here alone in this forest and I've nothing else to think about, I started thinking, how alone is the entire human race? That's you, me, and everyone else. Are we the only civilization in the galaxy? Oh, and I'm restricting this to just the Milky Way. That's our galaxy. It's where you and I both live. I won't start droning on about the physics of the 4D light cone and the differences between, what do they call it, the past, the future, and the elsewhere regions, because all that hurts my head, that sort of stuff. Today, I'll just say that everywhere outside our galaxy is just, it's too far away to think about. You know, the scale of it, it just makes my head boil. Let's not go there. So, I've thought about this for quite a bit because I've nothing else to think about. And I've used my calculator to work out the percentage possibility that there is other intelligent life in the galaxy. And the results of all my calculations are that the chance of there being intelligent life on another planet somewhere in our galaxy is, drum roll effect please, nil, zero, none. I would say there is no intelligent life anywhere in our galaxy other than right here on planet Earth, where we live. Oh, I'm not saying that there isn't life on other planets. You know, there almost certainly is. I'm talking about intelligent, sapient life. Oh, if English isn't your first language, sapient is different from sentient. My cat is sentient. You know, she feels the wind or the heat from the sun. She hears and sees things. She reacts to danger, etc., etc. But sapience, what humans have, it's an additional ability. Basically, humans can think about thinking. We have the capability to use complex language to discuss abstract concepts. As an example, I'm talking to you now about a question which at this moment in history, we can't possibly know the answer. We can't know the definitive answer. We have technological capability, and it's not just the ability to create tools and complex systems. I'll give you an example. At a very basic level, if it started to rain now, I could build a shelter, but my cat would just find somewhere to hide. You see the difference? So that's the difference. Now, I know that we'd all like to think or hope that the galaxy is teeming with other sapient civilizations, flying around in spaceships. But maybe this is based more on wishful thinking, Star Trek type things and Hollywood movies. And remember, there's plenty of evidence that we are alone in the galaxy. And there is not one single piece of evidence to say that we're not. If you think about it, we don't really have any spaceships. Okay, we've got a few, how do I describe them? Liquid-filled rockets that can just about carry humans to the moon and then bring them home again. Mind you, if there were any civilizations out in the galaxy with real interstellar flight capabilities and they came to visit, do you really think that would be a good thing for us, for humans? We can only really look back at our own history to see the likely outcome of them visiting us. It's almost always catastrophic for indigenous groups when they come into contact with more, how can I put this, technologically advanced people. I'm actually trying to think of any times when indigenous people came out on top. It's quite difficult. I really should prepare these videos, shouldn't I? Before I just sit in a forest and talk at the camera. Oh well, I'll make a script next week and pin it to a tree. Hang on, I've thought of 3 times when it turned out sort of okay for an indigenous population. Are you ready for this? These are the ones that I can think of. Tonga, Ethiopia and Thailand. In those 3 cases, the indigenous people had a centralized government. And most importantly, they had leaders who were shrewd enough to use the outsiders' own technology and their legal tricks against them. So if you can think of any more other than those 3 countries, let me know in the comments. I started to waffle there, didn't I? Let's get back to why I think we're alone in the galaxy. I won't be using the standard discussion points about this topic, which are the Drake equation and the Fermi Paradox. Oh, the reason for this is my personal reason for thinking that humans are the only intelligent life in the galaxy is just that we are here due to a very, very simple biological mistake that only ever happened once, just once. Let me explain. I'm trying to think of a good way of putting it. The Earth is approximately 13.8 billion years old. So the universe is approximately 13.8 billion years old, and the Earth is very approximately 4.5 billion years old. So before we carry on, I want you to think about something. You and I and all other animals on this planet exist because of a simple biological mistake that only ever happened once, and once only, during 1/3 of the age of the entire universe. You know, it's just, as I said, I'm not going to use the Drake equation or the Fermi Paradox. Oh, if you've not heard of them, the Fermi Paradox was thought up by a scientist, I think in the 1950s. His name was Enrico Fermi. The basics are that he asked why, if there's such a high probability that alien life exists, why don't we have any proof that it exists? And why haven't we been contacted by any, aliens? Basically, if there are aliens out there, where are they? That was his question. Later on, an astronomer called, I think his name was Frank Drake, he tried to come up with a mathematical formula which tried to answer the Fermi Paradox. His equation tried to answer how many civilizations were there out there, in space that we can communicate with. He used things such as the rate of star formation, the number of planets. The trees are going to fall over, I think. The likelihood of life developing on a planet, etc., etc. And the result of his mathematical calculations were, we don't know. That's the answer. But as I said, I'm not going to use those two because they both use the possibility that there just may be intelligent aliens out there. So I'm only going to focus on just how unlikely multicellular life actually is. In fact, it's so unlikely that statistically, you and I should not exist at all. Humans should just not exist. And yes, I know statistics can be used to prove or disprove virtually anything. I'm trying to think of a good example of it. What are the chances of winning the Euro lottery? About 1 in 140 million. But the chance that somebody will win is around 1 in 2. So, as I said, I really do think there is life out there, probably on billions of planets. In fact, I would guess that life exists on virtually all planets that are capable of supporting life. But, not too close or too far away from their star. Probably have some water and reasonably stable conditions. But the aliens that I imagine would look more like mold or slime than Mr. Spock or Jabba the Hutt. The reason I think this, and once again, if you disagree, let me know in the comments. The reason I think it is life itself is just chemistry. The kind of chemistry that happens when you have the right ingredients, which would be energy from a star like our sun, and you've got enough time. The Earth is very old. Now, this is all well and good. Sometimes someone can go and sit in a forest and wonder about sentient and sapient life. But before we go on, whilst we're still here sitting under a tree, which is alive, by the way, we do need to think about something else. What is life? What is the difference between something which is alive and something which isn't alive? Also, if we agree that something is alive, where did that life come from? Oh, and I have to be very strict about this. I'm not looking at this from a philosophical or religious or even a legal point of view. I'm just wondering how a lump of rock orbiting around a star came to have things on it that are intelligent. Well, not including me. I'm talking you're intelligent, not me. So these are my thoughts. Oh, and it's been a very, very long time since my school chemistry lessons. So if I get anything wrong, let me know. I'm sure somebody will. So here's my idea. The Earth formed around 4.8 billion years ago as a hot lump of rock whizzing around, the sun. Not long after this, we'll say about 4 billion years ago, the Earth's atmosphere was a mixture of gases, so methane, ammonia, water vapor, etc., etc. Energy from lightning strikes or sunlight triggered a chemical reaction in this, I'm trying to think what to call it, a soup of gases. Now, when energy, for example, lightning or UV sunlight, hits these simple gases, it breaks their existing chemical bonds. And this leaves atoms unstable and looking for something to grab onto. That's a good way of putting it. As they collide into this soup, they reform into new, more complex arrangements, like amino acids. And the reason they do that is quite simple, because those structures are more stable under those conditions 4 billion years ago. So it was inevitable that amino acids would eventually form sooner or later. Now, this is the reason that I think there is some form of life on billions of other planets. It's almost certain. But, and it's a big but, here's something to think about. Amino acids, I think they add to my idea that we may be actually alone in the entire galaxy. The reason for this is amino acids, they're often called the building blocks of life, of proteins. A simple way to think about them is that they're small molecules floating around. That's a good way of putting it? And when they link together, they form long chains. And these chains are called proteins. Now, on Earth, billions of years ago, there were lots and lots of volcanoes. I'm assuming that there were. And most volcanoes produce volcanic glass. And this is an ideal surface for simple chemicals to stick on and react. So the glass formed by volcanoes didn't just help build these protein strings. It helped them form into even more complex molecules known as RNA. RNA, let's have a think. You may have heard of DNA, deoxyribonucleic acid. Well, RNA, ribonucleic acid, it's a simpler, more mobile version. The main difference is that, and I'm desperately trying to think how to describe it, they both have the same amount of sugar molecules, that they use to build their chains. But the RNA sugar is, I'll put it like this, it's bigger because it contains an extra oxygen atom. But all that waffle is for a different video. Let's stay focused today. What was I saying? Oh yes, RNA is a simpler, more mobile version than DNA. You've probably seen graphics of, DNA. It's like a double strand. It's like a twisted ladder. Well, RNA is the same, but it's only got a single vertical strand. Okay, so it's a twisted ladder, but with only one vertical section. DNA stays where it is, holding the design plans that, for a bit of a body, and it tells it what to become. But RNA acts more like, it's like a courier, and it carries those instructions of what type of protein it should build. So RNA is a molecule that can both store information and make copies of itself. And that is the important bit. It really is. Because proteins can't do that. Proteins can't copy themselves. Proteins are the workers. They do the work. They build things, okay? And they keep everything running. That's a good way of putting it. But RNA is like a self-copying blueprint. You know, it's a set of plans that tells the workers what they should build. And it has this unique ability to duplicate itself, you know, to keep the project running, to get things growing bigger. So what you end up with is a partnership. The RNA holds the instructions, and the proteins, they do the work, okay? Now, when those two things come together, you've got something that is, it's starting to look a lot like life, okay? But none of that matters if they can't stay together. So on the early Earth, proteins and RNA were both forming, but there was still one very big problem. All of this, you know, RNA and proteins and all the other useful molecules, they were just floating around in the ocean. You know, there was nothing to hold them together. And this is where something really, really important happens. At the same time, you know, when all this was going on, the Earth was full of simple oily molecules, a bit like the fat in your body today, but much, much simpler. They were being made all the time. Some formed around deep sea vents where hot chemical rich water reacted with rocks and what have you. Others were delivered from space, you know, on meteorites. They actually fell out the sky. Now, these oily molecules have a very strange property. One end of them likes water, and the other end really doesn't like water. You can imagine them like tiny matchsticks. The head loves to be wet, but the tail tries to stay dry. So it's like, you know, wet and dry. So when you drop them into water, they don't just sit there. They automatically huddle together in a circle so that the tails are tucked safely inside, away from the water, and the heads face outwards into the water. The easiest way for them to do all this is to form a very tiny bubble. So all over the early oceans on the Earth, these little bubbles of fat were constantly forming into bubbles and then breaking apart, and then forming and breaking apart. Most of them didn't do anything. They didn't do anything interesting at all to do with our story. But every now and then, purely by chance, one of these bubbles would form, well, some of these bubbles would form around some of these useful molecules of RNA and proteins, and that changes everything. And I do mean everything, because now, instead of drifting apart, everything is held together in a tiny protective boundary. Amazing. So it can still let small things in, which are eaten, and they provide the raw materials and energy for the system to grow. Now, at that point, you no longer just have chemistry. You have something that behaves like a cell. Your body's made of cells. And when these bubbles grew too big, they would just naturally split in two, making identical copies. I told you this was, mind you, it's just... So now you've got something that can hold information, it can use energy, and it can replicate itself. And that is the point where random chemistry becomes, I'm trying to think of the words to describe this very carefully, a coordinated, self-sustaining system. Now, I find all that utterly remarkable. I really do. You start with a few atoms which bind together into molecules. These molecules arrange themselves into proteins and RNA, which they then combine. And then they're enveloped into a bubble of fat. These cells absorb nutrients. They grow and they replicate. And only from a scientific perspective, we now have something which is, are you ready for this? Which is alive. Chemistry is strange sometimes. These single cells would replicate by simply splitting in two, and the two cells would float apart and go their own way. Okay, so now I would guess that this type of thing, creating single-celled life, well, that's what we'll call it for today, purely from a scientific perspective, I would suspect that this will take place on any planet in the galaxy that has the right ingredients and the right conditions. But something interesting happened on the Earth about 2 billion years ago. Something happened to one of these single cells, a biological accident, and this changed again. This really did change everything. It wasn't meant to happen, but luckily for us it did. A cell split in two, but instead of floating apart, the two cells somehow stayed stuck together. This didn't just happen once, by the way, it happened a few times. And each time it did, it created a type of life, such as fungi, bacteria, plants. There's a few types of algae. But in the cases of animals like you and me, this simple clumping event, it led to you and me and my cat. And don't forget that this only happened once in over a third of the age of the entire universe. So that tiny blob of fat containing two cells became the direct ancestor of every single animal that has ever lived, from microscopic worms to dinosaurs, from jellyfish to humans. Evolution had begun. Every single animal that has ever lived on planet Earth is a direct descendant of that first little blob of fat with two cells inside it. Yeah. These first animal clumps found a clever way to keep going. Instead of the whole group splitting in two and replicating, they would release a single cell. That's called a seed cell. And that would swim away and grow into a brand new identical clump. And because they were now larger than all their single-celled neighbors, they could draw in more nutrients through their shared membranes. And even, this is a shocking part for some, they would begin to hunt the smaller cells. Okay, so this clumping strategy was so incredibly successful that these early animals quickly took over every available space in the oceans. And this is why multicellular animals only formed once. The first groups, the clumps, were so dominant that any other cells trying to start a new animal line was simply eaten before it could get past the two-cell stage. I think it's amazing. As I said, other types of multicellular life also formed, like plants and mushrooms and bacteria, etc., etc. But each of those, by the way, would need its own separate video. Today, I'm only talking about animals. So where was I? Oh yes. Earlier on, I mentioned that when talking about aliens in spaceships, The Fermi Paradox is used to ask, where are they? And the Drake equation is used to work out, why we've not seen any, why we haven't communicated with anybody. But there's another less well-known section. It's sometimes called the Great Filter, but I think it should actually be called the Great Filters, plural, because there is more than one. In fact, there's an almost unlimited number. Now the thing is about the Great Filter is that it's not just a question like the Fermi Paradox. It is, it's not a formula full of unknown inputs like the Drake equation. The Great Filter, quite simply, is a fact. As an example of a filter, the dinosaurs were filtered out of existence by an asteroid hitting the Earth. The dodo was filtered out of existence by European settlers. I'm trying to think of another one. Smallpox was almost filtered by vaccinations, etc., etc. So other filters they're happening all the time. A star could go supernova, nearby, and it could strip the atmosphere off a planet. Or massive volcanic eruptions could block out the sun for decades, causing problems. Or a simple change in a planet's orbit could turn a nice green world like the Earth into a frozen wasteland just by moving it slightly further away. So what is it? Well, if we assume, as I do, that life is almost inevitable, it will almost crop up given the right conditions and ingredients. There is something, a filter, which it stops these single cells forming and evolving into a spacefaring civilization, or something that can communicate. The theory is that almost nothing gets past the filter. Most people assume that the filter is in front of us, something which will put the brakes, it'll stop us dead. Just stop. It'll stop everything to do with humans. It could be a nuclear war. It could be a planet-wide pandemic. It could be a volcanic eruption, again, that blocks out the sun, for decades and decades. Another asteroid could hit the Earth and wipe us all out. Climate collapse, or it could even be some advanced technology that it just goes wrong, like ChatGPT or Google AI. The list is almost endless. Now, all of these things could happen, but it could be something that we haven't even imagined yet. We just don't know. But my question is, what if it isn't? What if the filter is already behind us and we've already come through it? Who knows? As I said, turning chemistry into simple life is, in my opinion, which may be wrong, it's probably not that rare. Turning simple life into single cells probably happens all over the place, all over the galaxy. It really does. But the next step, two cells splitting, and instead of drifting apart, staying together and working as one, that wasn't just slow evolution. It was a freak accident. And it was one, don't forget, that only happened once in 4 billion years. And then it took over an entire planet. And this means that it isn't just rare. It means that it's effectively impossible to repeat. Without that simple mistake, you don't get animals. You get no fish. You get no ants, no tigers, no you, no me. You just get oceans full of single cells quietly existing for billions of years. So when I say I think that we're alone in the galaxy, I'm not saying, again, that life is rare. I'm saying that this intelligent, sapient life is rare. Because if that really only happened once in 4 billion years on this single planet, then the chances of it happening somewhere else, I don't know. I think it starts to look very close to zero. What do you think? Okay, all this said, we don't have any proof either way. We only have one example to work with. You know, that's us, our own planet. So all this is a bit like saying, it's a bit like flipping a coin and saying, you know, it lands on heads. And then you try to work out how rare it is that, you know, it would land on heads, and you've only done it once. It doesn't work. Intelligent life might be, you know, that might be the real step. That first multicellular animal formed billions of years ago, and later it eventually led to animals like us. And we are just one outcome of that process. On other planets, if it happens at all, the end result could be very different. You know, you might have a planet full of chickens, or a planet full of worms, or dinosaurs, or jellyfish. You know, it doesn't have to be intelligent people that look like us or Star Trek. Who knows? So, as you and I probably really shouldn't exist, I think I'll take this opportunity to have one of my wife's flapjacks. Oh, she made these yesterday. My wife, by the way, will have to change her name legally now to Mrs. Map Reading. The flapjacks that she made yesterday, oh, look at this. She made, these are amazing. These ones are, I forget what's in them. They're, what did she say? She told me what? Banana and peanut butter. Oh, they are really, really good. And these ones, the other ones in there, these are, I forgot what they are. Some sort of, I've forgotten what they are. Ginger, that's what they are. So I've got banana and peanut butter, or ginger to eat. So I shall thank Mrs. Map Reading as soon as I get home. This entire video has just been all waff. I better get up and stop sitting in this forest. Anyway, thanks for watching.